Hello students, in our previous class we learned about quadratic polynomial and its properties. Properties means the relationship between the zeros and the coefficient of x square, x and the constant. Okay, and some problems which are related with these quadratic polynomials. Okay, in this class we will learn about cubic polynomial. Okay, so first of all we have to learn what is the general form of a cubic polynomial. Okay, then how it is related with its zeros and the coefficients of cubic term, square term, linear term and the constant term. Okay, so let us study about cubic polynomial. General form of a cubic polynomial is f of x equals to ax cube plus bx squared plus cx plus d, where the strict condition is a not equals to 0 and all are a, b, c, d are real numbers. Okay, so this is the general form of a cubic polynomial, that is f of x equals to ax cube plus bx square plus cx plus d, where the strict condition is a not equals to 0 and all the coefficients that are a, b, c, d are real numbers. Okay. Now, if alpha, beta, gamma are the zeros of the cubic polynomial, then by factor theorem x minus alpha, x minus beta, x minus gamma will be the factors of the cubic polynomial f of x. Okay, since this is a cubic polynomial, it has maximum 3 zeros. Okay, 3 real zeros. We consider those 3 real zeros are alpha, beta and gamma. Okay, so if alpha, beta and gamma are the 3 zeros of this cubic polynomial, then by factor theorem we can say x minus alpha, x minus beta and x minus gamma will be the factors of this cubic polynomial f of x. Okay, so we can write the polynomial f of x as f of x equals to some non-zero constant k into x minus alpha into x minus beta into x minus gamma, where K is a non-zero constant. Okay. So we can write this polynomial f of x by this way, that is some non-zero constant k into x minus alpha into x minus beta into x minus gamma. So this will give f of x equals to k into x square minus of alpha plus beta into x plus alpha beta into x minus gamma. So this will give k into x cube minus of alpha plus beta plus gamma whole into x square plus alpha beta plus beta gamma plus gamma alpha whole into x minus alpha into beta into gamma. Now, if we replace this f of x by this general form ax cube plus bx square plus cx plus d, then this will be equals with this, that is ax cube plus bx square plus cx plus d equals to k into x square minus k into x cube minus k into alpha plus beta plus gamma into x square plus k into alpha beta plus beta gamma plus gamma alpha whole into x minus k into alpha into beta into gamma. Comparing the coefficients of x cube, x squared, x and constant term from both sides, we get a equals to k, b equals to minus k into alpha plus beta plus gamma, c equals to k into alpha beta plus beta gamma plus gamma alpha, and d equals to minus k into alpha into beta into gamma. So this will give alpha plus beta plus gamma equals to minus b by k, alpha beta plus beta gamma plus gamma alpha equals to c by k, and alpha into beta into gamma equals to minus d by k. Now, if we replace this k by a, then this will be in the form alpha plus beta plus gamma equals to minus b by a. Alpha beta plus beta gamma plus gamma alpha equals to c by a, and alpha into beta into gamma equals to minus d by a. That is sum of the zeros of a cubic polynomial equals to negative of coefficient of x square, that is coefficient of square term, by coefficient of x cube, that is coefficient of cubic term. Sum of the product of the zeros taken two at a time is equals to coefficient of x, that is coefficient of linear term, by coefficient of x cube, that is coefficient of cubic term. Product of the zeros equals to negative of constant term by coefficient of cubic term. So this is the way by which we can get a relationship between the zeros of a cubic polynomial and the coefficient of its coefficient and the constant terms. So sum of the zeros of a cubic polynomial is equals to negative of coefficient of x square by coefficient of x cube. Sum of the product of the zeros taken two at a time is equals to coefficient of x by coefficient of x cube, and then product of the zeros is equals to negative of constant term by coefficient of the cubic term or coefficient of x cube. So this is the way by which we can find a relationship between the zeros of a cubic polynomial and the coefficient of x cube, x squared, x and constant term, that is coefficient of the cubic term, coefficient of the quadratic term, coefficient of the linear term and the constant. Okay. The then alpha plus beta plus gamma equals to minus b by alpha beta plus beta gamma plus gamma alpha equals to c by a, and then alpha into beta into gamma equals to minus b by a. So students, now we choose a cubic polynomial whose zeros are given, that is 3 minus 1 and minus 1 by 3 are the zeros of this cubic polynomial. That means these three numbers, that are 3 minus 1 and minus 1 by 3, will be the zeros of this cubic polynomial. This thing we have to verify this. Okay. So first of all we have to verify these three numbers 3 minus 1 and minus 1 by 3 are the zeros of this given cubic polynomial, and we have to verify the relationship between the zeros and the coefficient of cubic term, quadratic term, linear term and the constant term. Okay. So already we know these relationships, that is if ax cube plus bx square plus cx plus d represents a cubic polynomial and alpha, beta, gamma are its zeros, then we have alpha plus beta plus gamma equals to minus b by a, alpha beta plus beta gamma plus gamma alpha equals to c by a, and alpha into beta into gamma is equals to minus d by a. Okay. So let us study how we can verify this problem. Solution. The given cubic polynomial is f of x equals to 3x cube minus 5x square minus 11x minus 3. To verify three minus 1 minus 1 by 3 are its zeros, then if we prove f of 3 equals to 0, f of minus 1 equals to 0, f of minus 1 by 3 equals to 0, then we can say that three minus 1 minus 1 by 3 are the zeros of this cubic polynomial. Okay. So first of all, when we want to verify that three numbers 3 minus 1 and minus 1 by 3 are the zeros of this cubic polynomial, then if we prove f of 3 equals to 0 and f of minus 1 by 3 equals to 0 and f of minus 1 by 3 is also equals to 0, then we can say these three numbers 3 minus 1 and minus 1 by 3 are the zeros of this cubic polynomial. Okay. Now f of 3 equals to 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3, that is 81 minus 45 minus 33 minus 3, that is 81 minus 81 equals to 0. F of minus 1 equals to 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3, that is 3 into minus 1 minus 5 into plus 1 plus 11 minus 3, that is minus 3 minus 5 plus 8. 11 this is equals to minus 8 plus 8 equals to 0. F of minus 1 by 3 equals to 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. This is equals to 3 into minus 1 by 3 whole cube means minus 1 by 27 minus 5 into minus 1 by 3 whole square means plus 1 by 9. This is plus 11 by 3 minus 3. So this will give minus 1 by 9 plus minus 5 by 9 plus 11 by 3 minus 3. So this will give minus 6 by 9 plus 11 by 3 minus 3. This will give 3 3s are 9, 3 2s are 6 minus 2 by 3 plus 11 by 3 minus 3, that is minus 2 plus 11, that is 9 by 3 minus 3. This will give 3 minus 3, that is 0. So these implies that three minus 1 and minus 1 by 3 are the zeros of the cubic polynomial f of x. Okay, so this is the way by which we can verify that these three numbers 3 minus 1 and minus 1 by 3 represents the zeros of this cubic polynomial f of x equals to 3x cube minus 5x square minus 11x minus 3. Okay, now we will verify the relationship between the zeros and the coefficients of this cubic polynomial by this way. So let us study how we can verify these relationships. So therefore, for the given cubic polynomial, the zeros are 3 minus 1 and minus 1 by 3. Okay, so we can say that for this given cubic polynomial, 3 minus 1 and minus 1 by 3 are its zeros. Let these zeros as alpha equals to 3, beta equals to minus 1 and gamma equals to minus 1 by 3. So therefore, alpha plus beta plus gamma is equals to 3 plus into minus 1 plus into minus 1 by 3. That is 3 minus 1 minus 1 by 3. So this will give 2 minus 1 by 3, and after finding the LCM of 1 and 3, we get 3 as the LCM. Then this will give 6 minus 1, that is 5 by 3. Alpha beta plus beta gamma plus gamma alpha, that is sum of the product of the zeros taken 2 at a time, is equals to 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3. So this will give minus 3 plus 1 by 3, cancelling these 3 we get minus 1. So this will give minus 4 plus 1 by 3. So 1 becomes its denominator. After finding the LCM of 1 and 3, the LCM becomes 3. So this will give minus 12 plus 1, that is minus 11 by 3. Product of the zeros, that is alpha into beta into gamma, is equals to 3 into minus 1 into minus 1 by 3. Cancelling these 2 3, we get plus 1. Okay. So after verifying these three numbers, that are 3 minus 1 and minus 1 by 3, we can say that the zeros of these cubic polynomials are 3 minus 1 and minus 1 by 3. Now if we consider these three zeros as alpha, beta, gamma, then we get alpha equals to 3, beta equals to minus 1 and gamma equals to minus 1 by 3. Okay. So after representing alpha, beta, gamma in this way, we find alpha plus beta plus gamma. It becomes 5 by 3. Alpha beta plus beta gamma plus gamma alpha becomes minus 11 by 3. And then alpha into beta into gamma it becomes 1. Okay. Now comparing the given polynomial f of x equals to 3x cube minus 5x squared minus 11x minus 3 with the general form of cubic polynomial f of x equals to ax cube plus bx squared plus cx plus d, we get a equals to 3, B equals to minus 5, C equals to minus 11, and then D equals to minus 3. Since f of x equals to 3x cube minus 5x squared minus 11x minus 3 can be written as f of x equals to 3 into x cube plus into minus 5 into x squared plus into minus 11 into x plus into minus 3. Okay. So now if we compare this given polynomial with the general form of cubic polynomial, we get a equals to 3, b equals to minus 5, c equals to minus 11, and d equals to minus 3. So therefore minus b by a is equals to minus b means minus 5 and a means 3. So this will give 5 by 3. C by a is equals to, c means minus 11 and a means 3. So c by a becomes minus 11 by 3, and minus d by a becomes negative of, d means minus 3, the negative of negative 3 by a means 3. So this will give 3 by 3 equals to 1. Okay. Now if we follow these values, that is this and this, then we see that minus b by a is equals to 5 by 3, and here alpha plus beta plus gamma is also 5 by 3. C by a here minus 11 by 3, and here here alpha beta plus beta gamma plus gamma alpha, its value is also minus 11 by 3. Alpha beta plus beta alpha into beta into gamma, this is 1, and here minus d by a is also 1. Okay. So alpha plus beta plus gamma becomes equal with minus b by a. Alpha beta plus beta gamma plus gamma alpha becomes c by a, and then alpha into beta into gamma becomes minus d by a. So thus we can verify the relationship between the zeros and the coefficient. That is, coefficient means coefficients of x cube, coefficients of x square, and coefficients of x and constant term. Okay. So this is the way by which we can verify the relationship between between the zeros of a cubic polynomial and its coefficients. Okay. In our next class, we will learn how we can solve cubic polynomial problems. Okay.